Welcome back to the eighth session of our Atal Online 6 days FDP on innovating agri-tech for sustainable tomorrow, aligning with SDG goals. We have amongst us Mr. Gajendra Deshpande. So, welcome back, sir, for this second session that we have you back again after the first day sessions.
Thank you, sir.
Yeah. So, as a protocol and as my humble duty, I would still want to introduce the resource person back again. We are pleased to introduce Mr. Gajendra Deshpande, the founder and MD of Theta Dynamics and ISEC Security Solutions. With over 15 years of experience in the IT industry and academia, Sir specializes in areas such as cyber security, AI, Python, blockchain, and web programming. So holds a postgraduate diploma in cyber law, forensics from National Law School of India University, Bengaluru, and an advanced diploma in cyber security and data protection from Nalsar University, Hyderabad. He also a certified DSCI Rapid Ransomware Responder, GitHub Campus advisor, and Apple teacher. Sir has been an active contributor to the tech community, presenting and reviewing papers at prestigious conferences such as SciPy, PyCon, and JupyterCon. He leads the PyData and OWASP Belgavi chapters and has been instrumental in organizing events like Belpy 2021 and Django Girls Belgavi. Through his work, he aims to inspire and empower the next generation of IT professionals with latest skills and knowledge. We look forward to learning from his extensive experience and expertise in this field. So we are honored to have you back again, and welcome back, sir, once again, and over to you.
Thank you. Thank you, sir. Thank you, sir, for the kind introduction and giving me an opportunity again.
Sir. Our gratitude, sir. Thank you, sir.
Thank you, sir. Good evening, participants. So, today we are going to discuss the topic known as artificial intelligence and Internet of Things applications in agribusinesses. Now, if you see the theme of the FDP program, it focuses more on sustainable development goals. Now, AI and IoT applications help us to achieve these sustainable development goals because it helps us to optimize, it helps us to improve the efficiency of the existing system, and it also helps us to build new systems which are very helpful in achieving the SDG goals. So, there are two parts here. So there are some applications which are using only artificial intelligence. There are some applications which use sensors. So what I'm going to do in today's talk is I'm going to introduce you some more applications. So like I did in the first talk, but they were more focusing towards end user. But here we are focusing towards, say, maybe towards engineering aspects, or maybe towards management aspect, or maybe from developer perspective, or maybe from researcher perspective. So I'm going to introduce you tools and techniques. Even though you don't have programming skills, it's fine. You can do simulations by dragging and dropping the different components on the screen. So I will demonstrate those applications here. And after that, I have compiled some of the applications and majorly the problem statements. So if someone is looking for some problem statements and they want to work on those problem statements, I've listed some problem statements. Now these problem statements I have compiled from Smart India Hackathon. So what happens in Smart India Hackathon is it's a government initiative where they ask different departments in the government, like central government and also the state governments and also the corporations, to give the problem statements. So these problem statements are given by departments, ministries, and corporations. So you can consider them that it's a software or it's a problem that needs to be solved today. So they are all current problems. Okay. Now, so without going into any introduction and other stuff, I'm going to directly start with the presentation here. So I will be switching between the slides and the websites. So the first resource which I am going to discuss is there is something called as Awesome Agriculture. So it's a repository on a website called as GitHub. So GitHub is a version management system which is used by most of the IT companies. So they basically host source code over there, but not only the source code, you can also host the content over there. So likewise, if we go to web browser and if we go to the Awesome Agriculture repository here, so you can see that this is what you are going to see. So it's a curated list of open source technology for agriculture, farming, and gardening. Now, there's something called as open source technology and closed source technology. So closed source means companies are developing the products, and whatever they provide, you have to just use it. You will not be having any freedom to modify the source code or add your own features. But in case of open source technology, the entire source code is accessible to you. You can study the source code, you can modify the source code, you can build on the source code and get the solution for your own use case. Now, if we go to the Awesome Agriculture repository here, you can see that there are some categories. There is something called automation and robotics. There are some calculators, then climate, environment and weather, crop modeling, phenotyping and pathology, data sets, data standardization, interoperability and APIs, farm management, geospatial and GIS, IoT and hardware, knowledge bases and learning resources, machine learning and AI, then remote sensing and imagery. So in each of these categories, these contributors, you can see here there are more than 20 contributors here. If you want, you can also add the resource. If something is missing, you can go to the repository, create a pull request and add the resource. The maintainer of this repository will go through it, and if that person finds it valuable, he is going to definitely add it to the resource, and you can also become a contributor, and all these resources are free to access. Now if we go to the first category, that is automation and robotics, there are some tools, there are some softwares that are listed. For example, you have something called as ant robotics, then you have acorn rover, so this is for precision farming. Then there is something called as earth rover. Now some of these, if you consider here, especially in automation and robotics, you need hardware as well as software. But the beauty of these things is that you get the entire design here, so that you can replicate at your end. So source code is of course is provided here through the repository, but you can also design the hardware on your end. For example, if we go to something called the acorn rover, so you can see here this is the open source repository for twisted fields, and you can see here that there are repositories, as I have told you, that there's a source code for acorn, right? There's a PCB hardware design, and there's also mechanical design information for acorn, and there's also a motor controller. So that means whatever you need to build on your end, so those things are available here. So if we click on precision farming rover here, you can see that the source code is available here. Now you can also see the history when this has been updated last. Now if we see this folder, it says that 5 months ago, 5 months ago. Okay, so that means considerably it has been updated recently. Okay, so this is a software repository for acorn. So you can find the source code, and this is licensed under Apache 2.0. So you are free to use this source code for your personal use, but whatever modifications you make, you have to also share it to the community without charging anything. So this is the design of the rover you can see here, and they have also mentioned how you can run the code in the simulation. So there is simulation readme, and so you have to follow the steps mentioned here, install all the required softwares, run the appropriate scripts, configure, and you will be able to access this simulation. So this is one such tool. Likewise, you have multiple tools here. So you have also PyIto, that's a Python package for calculating potential evapotranspiration. So there's also PyTSB, again it's a Python based software. Now when you see these things, majoritarily you will find the source code in Python and also the R language. And now in recent days we are also finding the source code in Julia languages. Now which language to use, it depends on you. Right? Sometimes what happens is some features are available, or some modules or some libraries are available only in specific language. For example, if you want to create a software which is related to GIS, and plotting libraries related to GIS are very good in R compared to Python language. So in that case, you have to make use of libraries in this specific language only. So you have to clearly study here what are your requirements and see what kind of support is available in the language. And based on that, you can select a language. So don't select a language just because you like it, because that is not going to help you much. And you may have to put a lot of hard work to achieve the goals. Because if some feature is not available, you may have to write the code from scratch, so that's going to take a lot of time. Then if we consider here crop modeling, so you have something called as open plant pathology. It's a website, so that's a community here, so which believes in open data and computational tools. So if we go to the website here, you can find all the details. So you can see a plant rust images, open photo gallery for rusts from South Africa. So likewise, there are many other things. You can just follow this and explore. Then data sets. Now data sets are very, very important for us because we are discussing the topic of artificial intelligence. In artificial intelligence, there are many subfields like natural language processing, like computer vision, machine learning, deep learning. Right? So these are all subdomains of artificial intelligence. But all these things, they work on data. We need data. So likewise, there are some websites which have the data set. They have collected the data from the real world and prepared the data set. So sometimes these data sets are available for public use and you can use them without paying any money. Sometimes they are available as APIs. For example, the first one, growth stuff. If we click on it, it's going to open a website here and you can start browsing about these different crops. So if we click on tomato here, you can find the image data set related to tomato. So they are also displaying some data. For example, what is the median lifespan, first harvest expected, and last harvest expected, and those things. But if you see the photos here, so we have lots of photos. Okay, so now you can see it. We have lots of photos. Okay, so some photos are not available here, but you can see here many photos are available. Now this is going to help you because You are going to prepare a data set of images of tomatoes, and then you are going to analyze whether the tomato is good to consume or it is not good to consume, depending on its texture, right? So in that case, it's going to help you. So for that, you need data set, be it any vegetable, be it any. If you scroll down again, okay, fine. So similarly, you can also select different vegetable. For example, basil here, and again you are going to find the details. Okay. So this is just one example of data set. So similarly, you have another data set which comprises of field images, and you can download the complete data set here. Okay. And it's available to you free of cost. And this data set you have to feed as input to the algorithms. Okay. So we have images here and we also have annotations here. So that means we have to make use of computer vision libraries and also the machine learning libraries. So both of these libraries will give you different results. You have to combine the results of different types of algorithms and then make a prediction. So this is our data sets. Now many times what happens is that data set may not be available. So in that case you may have to create your own data set. Sometimes you may have to create synthetic data set, which is artificial data set, which will help you to test how your application basically works. Then you have something called as data standardization and interoperability and also the APIs. So now we are in an era of APIs. So API means application programming interface. So what happens in APIs and why we need APIs is that it is not possible for us to create all the applications from scratch. And because of APIs, we can develop any applications with much speed. For example, now we have ChatGPT, we have Google Gemini, right? So they are running the model in the backend, and those models are having billions of parameters. They are large language models. So we cannot create our own large language model and then create the application around it. It's going to take a lot of time if you follow that approach. But the simplest way is you go for the APIs, use ChatGPT API and build the application surrounding the ChatGPT ecosystem. Use Gemini APIs and build the application surrounding the Gemini ecosystem. So that is going to save a lot of time. Then you can focus on fine tuning the application and you can achieve whatever results you want here. Okay. So that's why you can see here there are many APIs here. For example, if we see, okay, so there's something called as OAuth API. So that means if you want to integrate authentication feature into your application, then you can just make use of this OAuth source code. And now you can see here the examples are mentioned in different languages. In C Sharp, it's there. In Java, it's there. In Node.js, it's there. In Python, it's there. So you can, depending on which language you are using, you can use these APIs and integrate. Okay, so there is some sample data from John Deere. So if you have any requirement, and if you can use this data and build application, or you can perform analysis, you can use this data. But this is with old data, 5 to 6 years ago. Then you also have some softwares like farm management systems and record keeping. And again, all these are free softwares. You have something called AgroSense, which is again free and open source farm management suite, which is built in Java. Then there is something called as Farm OS. Right? See, OS is again, it's not the operating system. They have named it like that, but it's a application which has been built using PHP and Drupal. So Drupal is built on top of PHP, which is a content management system. If we go to farmos.org website, we can see the features over here. So it's a web-based application for farm management, planning and record keeping. And the greatest thing is it is developed by community of farmers, developers and researchers and organizations. And they have developed it as a standard platform for agricultural data collection and management. And as I have told you, it's built on top of Drupal. So that means you can add your own extension, you can add your own module if it is not present in FarmOS, and you can use it. And it is also available as PWA. So PWA means progressive web application. The greatest thing about progressive web application is that you need not have to build separate applications for different operating systems. So single application, single code base will work for all the operating systems and all the devices. Okay, so you do not have to write Android code for Android OS. You do not have to write iOS code for iPhones. You do not have to write web applications for desktop applications. So that is not required. So single code base will work for all. So it's a community based tool. So if you face any problems, you can raise the query in the community and you can get the solution for your query. And it's, since it's developed using PHP and Drupal, it is completely open source, completely free. And you can see here you have this source code of FarmOS system. And you can see here it is updated very recently. You see the modules 2 weeks ago. So you can also become contributor. Yeah, there are almost 37 contributors here. And they have mentioned all the steps, how to install, how to use. You just need to follow the steps mentioned here. Okay, so likewise you also have something called the Equiliber, but it has been built with Ruby on Rails. Then you have SoilMate, which is the helper application, which will help you to collect the soil data. Then there's something called as Tanya, which is again a farming management system, but it has been built with another language called as Go. So there are different applications here. Then similarly, if you want to work with GIS, then you have something called Awesome GIS. So likewise, we have now Awesome Agriculture. So there is a separate resource for Awesome GIS, and you can find the resources related to GIS. So just like we have here separate categories. Then now, if we think of IoT and hardware, so we have AG Open GPS, which is a precision mapping and a section control software. So again, you will find the source code and the steps on GitHub website here. So as we have discussed, it's a precision mapping and a section control software. So you can find out the use case and rebuild on your local system and start using it. So likewise, you have dramatic, then you have farm data relay system, which uses ESP now and LoRa and other protocols to transport sensor data in remote areas without relying on Wi-Fi. So this is very important because we have discussed that in the first talk, we need applications which do not rely or which should not rely on internet and Wi-Fi. So that's why we have to use hardware which uses such protocols such as ESP now and LoRa. Now what these systems do is they collect the data and send it to the cloud, send it to the dashboard where you can analyze the information. So I can even show that. Then there is something called as farm hack. So it is nowhere related to hacking, but it's a worldwide community of farmers where you can get the solution for your problems. So again, they have some set of tools. So you can see here there are different tags such as smart farm, post harvest, planting, right, soil management, fencing and livestock, water harvesting, and so on. So you can explore this tool library, and if you develop your own tool, you can add a tool here so that people can use it. So you also have OpenMinder, which is a root zone monitoring system, and you have the APIs and you can build the application around it. And it uses something called as Raspberry Pi, which is a pocket-sized computer, very powerful computer. Then you also have the knowledge bases, such as Harvest Helper and OpenForm. Okay, now if we uh, visit this category, machine learning and AI, there are machine learning libraries which have been specifically designed for agricultural applications. For example, we have something called as AGML. So if you click on AGML, you can find the information, which is a framework for agricultural machine learning. So again, this is again a very well maintained library because it is again updated recently. You can see here 2 weeks ago. Okay, so this is a Python based library. So most of the code is written in Python, and you can also join the development of this project. So you can see here they have already mentioned we are looking to hire a postdoc with both Python library development and ML experience. So you can install this library using pip command. This is how you import the library, import AGML. Then you have to use a loader object and load appropriate data loader. So that is apple flower segmentation. So depending on the use case, this value will change. And similarly, you can write the code, and you can see here this library specifically focuses on agricultural applications. So here general Python will not help you. So you have to specifically learn AGML where you can write a shorter code compared to the generic Python code, and you can achieve the results faster if you learn this. Okay, so they have included these code examples, and you can also see here there are some data sets, and all these are public data sets, right? So you have image classification, semantic segmentation, right? And you can see the data has been collected from multiple countries. And it also mentions the number of images in every data set. So some are really good, some may not be sufficient. In that case, you may have to add more images to get the better results, because uh, this content is not enough to make prediction or classification. Only on 42 images you may not get accurate results. Then if you are working on R language, then you can use this package. Again, it provides lots of data sets from agricultural experiments, but this is again R specific. But again, this is also very well maintained, but you have lots of data sets. So in this case, you can just mention which data set you want to use and write the R code, and again you will be able to do the same things whatever you were able to do with AGML. That is prediction, classification, clustering. You can do it with R language also here. So similarly, you have some other applications here, crop yield prediction. Then you are having deep learning for biologists with Keras. Again, Keras is a Python library. Then you have AI, which is a multimodal geospatial machine learning model for agriculture and sustainability. This is from Microsoft. So if we click here, yeah, so you can see here microsoft.github.io. This is from Microsoft. Again, this is also a very well maintained library, because you can see that it has been updated last week, and you can follow the library here. And they have provided something called as notebook. Now these notebooks are Jupyter notebooks. So you have to just install the required softwares, install the Jupyter notebook, and they have the code examples, and you can just go on executing the code examples directly over there. So it's not at all a complicated process once the Jupyter notebook is installed. And you can see here what are the different types of notebooks they have included here. They have notebooks for performing crop analysis, cropland segmentation, deforestation, index computation, remote sensing, segment and anything model, right? Time series analysis, water management, weather forecasting, what if analysis. So all these examples are available in the form of notebook, okay? And you will be able to perform all these tasks. For example, if I click on water management, you will be able to perform field level irrigation classification and also the irrigation classification. If I click on weather, you can perform land, you can compute land degradation, and also you can make microclimate prediction. So all these functions are readily available. You just need to pass the data and get the results. So it is that simple. So similarly, you have for remote sensing, again you have Awesome Sentinel, which is for Sentinel satellites and data. So similarly, you have Awesome Vegetation Index, which is list of reference applications for common vegetation indices and hyperspectral and UAV images. So depending on a requirement, you can use these resources. Again, you can see here all this is in public domain. You can use it without any problems. So this is one of the useful resources. Okay. Then next, I wanted to introduce a website called as Kisan AI. Again, it's a wonderful website. So if you go to Kisan AI, okay, it's here. Okay, so they have these three softwares. One is Kisan Copilot, Agri Copilot platform, and Denu Agri models. So Copilot, you might have already heard about Copilot. It's from Microsoft. It's just like ChatGPT. So you can interact with the AI system to get the answers related to agricultural questions. So if you click on it, you can see here Kisan.ai and it says chat, and you can select the basic questions here because some people may not have any idea. You can also select the language. So right now I have selected Kannada language. So if I click on this question, ಮಣ್ಣಿನ ಸ್ಥಿತಿಯನ್ನು ಸುಧಾರಿಸುವುದು ಹೇಗೆ? Okay, so that was a prompt here, and you can see here it has given you the answer. Okay, you can also ask specific questions. So you can see here ನಿಮ್ಮ ಪ್ರಶ್ನೆಯನ್ನು type ಮಾಡಿ. So you can ask the specific questions and get the answers here. So similarly, you change the language.
Sir, sorry to interrupt, sir. Can you just show us even the English version as well?
Yes, sir. I'm
Uh,
switching
just
to
for the
English.
diversity of the participants who are there with
Yes,
me.
sir.
Yes.
Yes, sir.
Thank you,
I
sir.
was about to select the language.
Yes, yes,
So
yes.
let's select the English language here. And you can see that the same question is now asked in English. Okay, how to improve the soil condition. So if I click on it, it's going to give the answer in English. Okay. The same answer is given in English. So there are several ways to improve soil condition in India. Okay. So same question. You can select Marathi also. So you can also see here. So it says the same question in Marathi as well. Okay. Now some of you may ask a question. Uh, why we have to use this Kisan AI and why not the existing ChatGPT? The answer for such question is that ChatGPT, Google Gemini, all they are generic models. Okay, but this Kisan AI, it's a specific large language model for agricultural use cases. So results are better here. Accuracy is more compared to the ChatGPT's results. So you may have AI hallucination with respect to ChatGPT. It may create artificial results or hypothetical answers. But those scenarios can be reduced when we use specific LLM or when we use specific large language model. So that is the greatest advantage we will be having here. So let's go back. You can just note down this URL, that is kisan.ai, and you can explore it later. Now we have something called as Copilot platform. This is a generative AI knowledge platform. Now there's something called as request sandbox. This is not publicly available, but if you click on request sandbox, you'll get a Google form. Again, it's a pioneering vernacular generative AI platform for agriculture vertical. So it enables agri-businesses to assist their farmers and sales teams by conversationally delivering knowledge and product information. So you can fill this form and the team may contact you and they may give you the access and you can explore the platform, and if it is useful you can use it for your use case. So this is not still publicly available. Then the third one is something called as Dhenu, which is the agri model. Okay, so you have this website called as dhenu.ai, which is specifically agricultural chat GPT, you can say. And you can see here, you can start typing the prompt. Now, on the right hand side, you can see there are some models which they have mentioned. So Dhenu 2 in 8 billion. That means, so this model uses 8 billion parameters. Then there is version which uses 3 billion parameter. Then there is version which uses 1 billion parameter. And they also mentioned something called as max tokens. But to start using it, you have to create a API key. So I had already created the API key and I had named it as test. So I can start typing any query here and it will start giving me the answer. But if you want to explore, you have to go to the option called as API keys here, and you have to click on a button called as create API key. So once you create the API key, that will appear in the playground here. So you just need to select the API key and start using it. So you can start typing your query. Yeah, so type a message. So how to improve soil quality. Okay. So you can now see here it is giving me the answer. Okay. But you can see here it is not giving me long answers like the previous one because we have restricted the number of tokens. But it is giving me the answer. So you can also go for the documentation and you can install this. Again, this is a Python based code, and this is how you use it. This is the basic example. So first you have to install the OpenAI library. After that, import the OpenAI library. Then specify the data. Specify the prompts here. For example, the role is user content is how to take care of mango tree. So this is the query which we have inserted here. So likewise, there are some more examples. You can explore it later. So you can see here, if you want to create the application surrounding it, then these are the rate limits. Okay, so if you use the first one, that is Denu 2 in 8 billion preview, then the request per hours are 100, then per day it's 1000 and tire it's free. Now you can see there is something called as Llama 3.1 that is mentioned. Okay, so Llama is a open source model created by Meta company. So you can use any base model if you want to create your own LLM. Okay, so you need a base model. So and Llama can be one of the good choices, but it's not the only one. You can use any other base model. You can use ChatGPT also and customize it. Okay. So likewise, there are some more applications here. So they are planning to release few more. The vision, climate. Right? So they are planning it in December 2024. Not yet released. But if you want to create the application surrounding Dhenu, you can use it. Now the entire large language model is available on Hugging Face website, and you can access it. So I had created the organization settings already. Okay, fine. So this is about Dhenu. So that's the Agri model. So now the greatest advantage of generative AI is that it is democratizing the entire process. So that means anyone can start creating the use case. Anyone can start using the AI for their use case. Okay, so it's that simple. So we also have the use case for ChatGPT. That also we can cover. Okay, okay, that's the next. So if you consider chat GPT here, yeah, okay, here it is. So now on the left hand side, you have something called as Explore GPT's button. So I use commercial version of Chat GPT, but you should be also access these GPTs, and you get this interface. Okay, and here you should start typing about your use case. Now, if I say agriculture, you can see here there are already many GPTs or customized Chat GPT versions, right? So created surrounding agriculture. Okay, for example, there's something called agriculture mentor, right? It provides practical farming advice. Already 5,000 plus people are using it. Okay, then you have digital agriculture. Again, it provides agriculture optimization advice. So how to use it is you can just select any GPT here. There's something called agriculture entrepreneur. Okay, agriculture tutor. Okay, so let's select maybe the first one, agriculture mentor. Okay, again, you can see here there are some default prompts. So you select anyone and you'll start getting the answer here. Okay. So in the backend, ChatGPT's language models are running, but this is for your specific use case. Okay. So people have already created these smaller GPTs or GPTs for specific use cases. You can explore these GPTs for your particular specific use case. Now you can also build your own GPT. For that, you can go for My GPTs, and you can see here there's an option to create a GPT. It's here. It says customize the version of ChatGPT for specific purpose. So that is the main reason why they have provided this, right? So there's something called as configure. So in configure section, provide the name, provide the description, provide the instructions. Then you have to provide the conversion starters. So conversion starters are example prompts. Then the knowledge, right? So you can upload the specific files here, and you can also mention the action, what it has to do, and done. And when you click on create, your GPT will be ready, and you can make it public. People can start using it. So similar example we had seen with respect to notebook LM in our previous session. Okay, so that's all about ChatGPT. Okay, then we have something called a geocracy. So Reliance is everywhere. So they have even created the application with respect to agriculture. There's a website called as Geocracy, and they have also done something interesting. Okay, so now if we go for Geocracy solution, they have two solutions here. One is automatic weather station, which is the agricultural IoT device based smart agriculture solution. And second one is the ET solution, that is for transpiration. It is app-based sensorless smart agriculture solution. So in the previous talk, someone had asked a question regarding the sensor maintenance and replacement. Now there are solutions which are coming up where they are not relying on the sensors. So this is one example. So which is app-based solution and not the sensor-based solution. And they have the Android application here, and they have the geo device, right, which has some sensors, Say for example, if you want to measure the moisture of a soil, then they have a sensor which you can just put it inside the soil and it will measure the moisture in the soil, and it will send the data, and their platform will give you the recommendation what you have to do. Okay, so you can explore this. And apart from that, they also have something called a geokrishi bazaar and geokrishi seller, which is a marketplace. Okay. Then next we have something called as farm beats. This is from Microsoft. Okay, farm beats. So you can see here. So they are focusing, or they are working on something called as the data driven farming. Okay, so data is very very important for this. And how they are collecting the data? They are collecting the data through sensors and devices like drones. They are taking the pictures of the farms. They are also taking the pictures from the satellites, analyzing all the data, and they are making the predictions. And based on the analysis, they take the action. So the reason why they have started this project is that, so they say that there needs to be a significant increase in the world's food production by 2050, but there is limited amount of additional arable land and water levels. Okay, and so that's why they are using the technology so that they can use the limited resources and achieve better crop yield here. Earlier it was started as farm beats, but now they have changed the name. Now it's called as Azure Data Manager for Agriculture. So you can access it free of cost. So you'll get $200 credit when you create the account on Azure, and that you can use it for 1 month. So you can also see the people who are behind this project, and maybe you can contact them if you need help with respect to your specific use case. And you can also go to the publications list, okay, and read the recent advancements. And they have something called as farm beats for students, where they have created tutorials for students. Know where it is, maybe we can search directly. Yeah, farm beats for students, it's under Microsoft Learn. So they have already created the tutorials here, so which will give the introduction to farm beats platform. Okay, so again you can use this hardware called as microbit raspberry pi and learn about this platform. Now you can see here they have created the tutorials, right, for grades 6 plus and ages 11 plus, and also 9 plus and ages 14 plus, right, then also the 9 plus and age 14 plus. Okay, so there is a tool called as make code which people can use to write the code. Okay, and this is web based tool, you do not have to install it and create the simulation. Okay, so students can do the experiments here. If anyone wants to understand how this platform works, so they can explore this farm beats for students. So what they are doing, they are first gathering the data to sensors, then analyze the collected data, then unlock the insights. So these are the three steps they follow. And after this we have something uh, here. I think name of this website, maybe Think Speak. Let's see where it is. So here it is, irrigation management. Okay, so it's a IoT based solution here. So this is the example for smart irrigation solution, and you can see the demo, and you can have a feel how this particular application works. There are some other applications also, such as air quality monitoring, waste management, and tank level monitoring. But we are focusing on this smart irrigation system. Now, when you build the dashboard, it's going to look something like this. So you can see here they have marked the field, right? So there are two fields. One is for wheat, and second one is for corn, and it is showing the average moisture. Okay, so for wheat it is showing 23.9, for corn it is showing 26.8, and it's changing. Okay, so you can see here it is for last 5 days data. Okay, from November 29 to December 5th. So we have this data. If we click on any one of these, so now you can see here it says irrigation status is off. Okay, average moisture is 24%, and there are three critical alarms. And what are those alarms? You can see here low moisture level. So this is the notification. So when you install sensors and when you're collecting the data frequently, you get these alerts. So this is the major advantage, and you can access this platform from anywhere. Okay, and because of these critical alarms, right? So you can enable other features and make sure that you have proper average moisture level. Now you can also edit the moisture sensor, or you can delete the moisture sensor. Now you can see here in the screen, right, in the same field, that there is a moisture sensor where the average moisture level is 28.2%. This is good, but there's another part where it is 22.6%. So this is how you can use sensors, IoT, and implement smart irrigation system with respect to your farm. So similarly, if we select the other one, okay, that's the first second one. Now for second case, we have only one critical alarm. Okay. So again, low moisture level for specific sensor. So in this case, there are four sensors. You can see here, one in each corner. Okay. So this is below the average. So that's why we have got the critical alarm here. So you get all the data about your farm, right? You get the insights and information because you have deployed sensors in your farm, and that have been, and those sensors will collect the data and send it to the dashboards like this. And where this dashboard is hosted, this dashboard is hosted on a cloud. So there is a code written in the backend, okay, which will analyze the sensor data, and it will generate the alarms. Okay. So these are some of the applications here. Now, some of you may ask, right now, what we don't have any programming experience, but still we want to make use of AI/ML and do some analysis. So for that, I'm going to introduce a tool called as Orange. It's a Python based tool, and everything works with drag and drop. There's already an example which I have opened, but you can drag and drop anything here, right? And you can see the results. So this is a very basic example which works on iris data set. Okay, so where we are going to classify the iris flower. Now if I click on this file, you can see here there are parameters in iris dataset: sepal length, sepal width, petal length, and petal width, and the classification. Now, if I want to use it, if I want to see it in a table, there is a data table component which I have to drag and drop, and I can see the entire data here. So now in AIML, what happens is that there are different algorithms, and we don't know which algorithm will give you better results for the specific data set. So how you can evaluate that? If you start writing the code, you may have to spend a lot of time, right? So you do not have to do all that. So now what we are doing here is we are using these three methods. One is logistic regression, second one is random forest classification, and third one is support vector machines. Now there is a component called as test and score. Now when I click on test and score, it is showing what is the performance, okay, for every algorithm I have selected. Okay, so area under ROC curve, if you select logistic regression for random forest learner, it is 0.746. For SVM learner, it is 0.387. For random forest learner and logistic regression, here it is 0.254. Okay, so there are other parameters also here, like F1, like precision, like recall. Okay, and you can take a decision based on these results. Okay, so this is as simple as that. Now, if you want to test some another algorithm, it is very simple. I'll just show it in a minute. Okay, so KNN is not there, so I'll drag and drop KNN. Then I'll draw the line from KNN to this core, and now I'm going to double click, and you can see here KNN row is added. All the computations are performed. So it is that simple. Drag and drop. Right. So this is how you can use this orange tool. Okay, and work on your own data set. So you can work on standard data set, or you can create your own data set and apply these different algorithms and see how it works. So similarly, you can get the confusion matrix, okay, for every algorithm. See here. Okay, so it is that simple. So this is a very useful tool who don't have any background with respect to programming. Okay, there is another tool which is similar to Orange, that is called as Nime. So the spelling is KNIME. So it is KNIME. Again, both of these tools are free, and you can download and install them on your system and start using them. Now, after this, we'll quickly go through some of the problem statements which I have collected, and you may ask questions with respect to these problem statements regarding the implementation. So we have seen one application already, that is smart irrigation system, right? So that is for here. So you can consider the problem statement. Water scarcity is a major challenge in agriculture, so leading to inefficient water use and reduced crop yields. So traditional irrigation methods often result in overuse or underuse of water. So here, some ministry wanted students to develop the smart irrigation system that utilizes sensors and IoT technology to monitor soil moisture levels and weather conditions. So one dashboard I have already shown you. Okay. So the expected solution is the smart irrigation module integrated with moisture sensors and a mobile application to provide farmers with timely irrigation alerts and recommendations based on real-time data. Okay, so this was the solution they were expecting. Then if you go to the next problem, that is drone-based intelligent ET sensing system and irrigation water use accounting system for irrigation commands. And if you consider the background of this problem, the use of Earth observation satellite technology for estimation of seasonal actual evapotranspiration of crops at various growth stages is well established. Now you can recollect here, Geo is also providing this ET solution. So due to low levels of water metering in irrigation, it is challenging to control theft from canals and unauthorized groundwater extractions. So therefore, ET-based technologies can enforce water accounting or auditing and thus enhance water use efficiency. Okay, so this was the background. Then expected solution, it is bit long. So here what they are expecting is a drone should be fitted with suitable ET sensing system to bridge the data gaps or limitations from satellite-based ET system for calculation of actual evapotranspiration of different crops under survey. Now here they are expecting you to use AI/ML algorithm using the historical data. So historical data means you need a data set here. And satellite based input should be able to give various key performance indicators at farm level, like type of the crop, crop monitoring, water auditing, water accounting, over irrigated versus under irrigated, and so on. Now if you consider this solution with geo solution, it is totally different. So there they are not using drones. So here they are suggesting you to use drones. But again, you can think which is cost effective solution and work on it. And similarly, we have another problem, which is again a drone-based intelligence system for apple orchard management in Himachal Pradesh. And we know that the Himachal Pradesh climate is suitable for apple production, but there are some problems also here. And basically, here they want you to use modern technology, particularly the drone-based systems, to enhance the efficiency, accuracy, and profitability in orchard management. So what they want you to do? So they want you to monitor the tree health objective. They already mentioned the methods. One is multispectral imaging. Second one is thermal imaging. So you have to make use of either multispectral cameras or thermal sensors or thermal cameras to collect the data. So likewise, there are some more objectives are mentioned here. So if we go through the expected solution, so they are expecting you to develop enhanced tree health monitoring system where improved early detection of health issues of the tree, then efficient nutrient and pest management, then accurate production estimation and innovative marketing tools. It's a bit larger project, but you can select one aspect of it and work on it. Then mobile app for direct market access for farmers. There are already some marketplaces which have been created by government agencies and some NGOs, but still they are not finding them enough or promising. So they are expecting, or they were expecting a promising solution here. An AI-driven crop disease prediction and management system. There are many researchers who have worked on this problem, but the problem is that it ends at only publishing the paper, so it is not materializing into a product. So that is the main problem here. So that's why the ministry is expecting that someone should provide them this solution. And another biggest problem is that once the application is developed, deployed, and once people start using it, it has to be maintained. New features need to be introduced. It has to be upgraded. It has to work on even new devices. So that is another challenge. Then there is another problem, that is sustainable fertilizer usage optimizer for higher yield. The background is that excessive and improper use of fertilizers leads to soil degradation and reduced agricultural productivity, negatively impacting the farmer's income. So they want you to create a data-driven solution that recommends optimal fertilizer types and quantities based on the soil health, crop type, weather patterns, ensuring sustainable agricultural practices. Now again, for this you need a data set. So you have to analyze the data and get the insights and provide the recommendations. So there's another platform which they are expecting, that is assured contract farming system for stable market access. So earlier there were some problems which were focusing only on market access, but now they want stable market access. So that's why they want a platform which addresses this problem. So they are expecting the online marketplace that connects farmers with potential buyers, offering tools for contract management, price negotiation, and secure payment processing. Then there is a problem. Again, development of AI/ML based models for predicting prices of horticultural commodities such as pulses and vegetables. Again, to perform prediction, you need data set. Okay. So already there are some economic models which uses ARIMA model, but we know that in statistics there are many other models. And if you go to programming languages, you can use these multiple models and test and check which gives you better estimates. Then similarly, we have farmers disease diagnostic or reporting portal, again which is AI based. The background is agricultural productivity and food security are heavily dependent on the health of crops and livestock. So farmers, especially in remote or resource limited areas, often face challenges in diagnosing and reporting diseases that affect their livestock and crops. So they need intervention here in early diagnosis and timely reporting for effective disease management and prevention of widespread outbreaks. So again, there are solutions like it works on again the data collection and analysis, and they are expecting cost effective disease management. So again here you need to make use of artificial intelligence techniques for disease diagnosis and for prevention and recommendation. Then there's another problem, that is use of digital knowledge sharing platform like wikis on sharing water efficient techniques and methods for minimizing water scarcity. So here they are expecting people to build website like Wikipedia, but for efficient water techniques. Then forecasting future water requirements and assessing storage capacities in reservoirs. This is another problem where you can apply AI techniques and do some prediction and do some analysis, and this will help the policymakers to have good insight about water management issues. Thank you everyone for listening to my talk. I can take up some questions. So there is one question: what challenges might arise in collecting and analyzing soil and weather data? See, the problem here is you have to make use of sensors, and it again depends on what are your goals. Okay, so either you use sensors or you contact the departments, right, where you can get the standard data. Okay, so that is important. And how can system address inconsistencies or inaccuracies in data inputs? That is where you have to work. Okay, because one of the important aspects in machine learning is data cleaning. So if you let the inaccuracies in the data, if you let the inconsistencies in the data, then your results will also not be accurate. You also need to identify outliers and remove the outliers. Okay, remove inconsistent data, right? So there is a separate step in machine learning. So that you have to use. That is data cleaning, data munging, right? So, what is the role of NDLM in supporting this initiative? How will system prioritize and handle cases where disease is not recognized by AI? So, the goal of NDLM is to create the awareness, and that's how it's going to help farmers creating the awareness regarding different initiatives. And how will the system prioritize and handle cases where the disease is not recognized by AI? See, here you have to take the results of AI with a pinch of salt. So you cannot completely rely on AI's results, because we have seen some cases where AI has suggested recently, I think just 2 weeks ago, it had suggested some student to die. Okay, so you cannot completely rely on AI. Yeah, any more questions? Welcome, sir. Is there a comprehensive open source database listing all agri-tech companies and incubators across India? I don't know about universal database, but if you go to the websites of ICAR and other websites, they have some PDF documents, some articles where they have listed some companies. But for incubators, you have to really find out who are these incubators who support agri-tech. Okay, because each incubator has some focus. So not all incubators work on all the areas. Okay, so you have to really find out who are those incubators who support agri-tech. So next question, what are the steps being taken by the startups and the government to train the farmers for using these AI tools? They can have social media, they can make use of effective use of social media and share the content. But the recent trend is they cannot make long videos. Maybe they may have to explain things through short reels. So that may be the effective solution. Startups may not be involved in creating the awareness because they are busy in working on their product, but government agencies and NGOs can do it. Are there any government funding schemes for institutes where training sessions for farmers can be conducted on AI? Uh, you can collaborate with government agencies. That is one solution. Second solution is maybe try to find out funding under CSR projects, corporate social responsibility projects by agri-tech companies. Any other question, you can unmute yourself and speak, or you can just type in the chat box. Can AI enabled credit scoring can be made for agri finance? You can make a survey, sir, and you can explore if it is possible. You can definitely go for AI. AI will not stop you in implementing it. No technology will stop you for implementation, but you just need to find out the use case.
Okay, I think and we'll wrap up the session today. Uh, is there anything else? Yeah. Gajendra sir, it was really nice to have you today and to listen to a very informative and a detailed session on AI tools. And it was really nice to listen to you with various ways in which in agri-tech these applications are happening. These applications are happening. Really, thank you for being with us. And on behalf of IMER team and Atal FDP team over there, we would like to thank you for being and sharing your valuable ideas over there.
Thank you, sir, for the opportunity, sir.
Thank you. Thank you. People
Thank
are
you, sir.
asking for your contacts. Please put it across. They would be really love to get in touch with you. Thanks a lot.
Sure, sir.
Yeah. Thanks.
Thank you, sir. Thank you, sir.
Yeah, the feedback link has been shared in the chat box. Kindly go to the feedback link and just complete the process.